Thank you, Mark.
Thank you so much, and thank you for inviting me to this talk. As Marcel said, I was in Paris earlier, and I live in Washington, D.C., and rotating through New York. So it's been, for me, quite the travel, but this is the fun part. So it's really a privilege to be here, and thank you very much. I'm going to talk, so y'all have heard a lot of technical talks and talks about capability in AI and companies and markets. I'm going to talk about something a little bit different, which is the role of philanthropy. So if you think about AI, it's exploding, right? It's huge and getting bigger. And from where I sit, there are two explosions. One is the companies powered by venture money, private equity. It is enormous. The other is academia and nonprofits. And it's not as big or as bright as the companies, but it's still there, and it has incredible advantages in terms of the brain power, the skills, the talent, and the students. And it's my job in philanthropy to make the academic and nonprofit sphere brighter, so that they can create the new ideas and explore all the high-risk areas which are not maybe adequately explored by industry. So that's my job, and we'll talk a little bit about philanthropy today. So philanthropy, as Marcel said, always makes a difference. And these are our two founders, Eric Schmidt, who was, as you know, one of the first CEOs of Google, grew Google from something small into something enormous, later chairman of Alphabet, and a very wealthy individual. And his wife, Wendy, who is also incredibly smart and incredibly concerned about these things. And so what they have done is taken a portion of their wealth and devoted it to charitable causes, in particular causes in the sciences. And so you can read the quotes from Eric and Wendy. I think it's very inspiring. This is so one of the elements of the Schmidt's charitable giving is Schmidt Sciences. This is where all of their science giving runs. This is work in foundational science. And the job is to accelerate scientific knowledge and build tools to do so. So what do we do? Well, you can read up here, but basically we take risk. We take risk with professors, with students, with nonprofits to try and explore ideas before they are picked up by the big money, which is public sector funding, the big research areas of the government. And so you can think of this as a two-stage thing. We take that initial risk. We are not afraid of failure. We often write the first check to a professor or a set of students. We help them, we guide them, and if they are successful, we celebrate with them. All of our work is public purpose. That, in this case, means essentially open source everywhere. We are directed through the United States tax code that any work that we do has to be in service of a public good. I think that's true of every philanthropy, but it's something we take extremely seriously. So we have 5 areas of philanthropic giving, which we work in. Astrophysics and space. We have lots of work on extraordinarily esoteric stuff about stars and sensors, and I don't understand most of it, but it's very cool to go to their talks. AI and advanced computing, which is my team. Science systems, which is essentially supporting postdocs and promising people around the world. A big effort in climate modeling and understanding the evolution of climate. And finally, some work in biosciences, primarily biomanufacturing, So not biomedical work, drugs. We think that that is pretty well covered currently. And so we are addressing sort of biomanufacturing in that group. So a number of sort of ways to explain what I have just said. So what do we want to do? We want to accelerate groundbreaking research and technology. And so what does that mean? That means, in particular, when we fund something, we kind of want to see a statement or a reason to believe from the proposer that their idea, whatever it is, could not have been done 5 years ago. That's pretty simple. That says you're kind of on the leading edge. Whatever it is, you couldn't do it then, and then something changed, and you can do it now. So we want to, out of that, support rapid prototyping, testing, and scaling. Usually this is a weird and wonky idea. Non-transformer approaches to AI, certain approaches to safety fall into that category. That's kind of where we want to go. We want to look at, as I say, we have an appetite for risk. And you can think of this, VCs, venture capitals, often have the same kind of appetite for risk. Because what they are trying to do is find the one payoff that will support all the rest of their investments that didn't work. The usual VC ratio is you want one spectacular success out of every 20 you expect. Out of those 20, 2 or 3 might be reasonable businesses, and the rest will be failures. So that's the kind of ratio. And we look, not quite that risky, but we look at that kind of thing to try and find that level of risk. And oftentimes that's interdisciplinary. Oftentimes that comes out of ideas. And so we set up lots of convenings and things like that to get those ideas. And then get them before they are at a level of maturity where the public sector in the United States, that would be our National Science Foundation or DARPA, or NIH, will start to fund them. And finally, we have a thesis that a lot of the kind of ideas which we have come from working across academic boundaries. Academia, departments are structured into groups, into disciplines, and this comes historically, and there's lots of good reasons for it, but there's nothing unique about the kind of structures which academia has. It's just tradition. It's worked for us for many hundreds of years. And so we look oftentimes at those boundaries. So those are our theses about how we make science happen. And now if we think about AI, this is my goal, right? This is what my team does. And so we have a couple of different tactics for this. So one is to advance the science of AI. So this is something where you'd think, well, the frontier labs are doing this. To which I say, not quite. The frontier labs are doing a thing, and they are scaling, and they are desperate to get to AGI and economically viable uses for AI before they run out of money, because it's so expensive. We're operating on a slightly different time scale, and so we're able to take more risks around the science of AI, around robustness, reliability, safety, and we have a fairly optimistic view that AI, there are risks, but there are also benefits. And how can we create AI that is sufficiently safe to capture those benefits? We want AI to be able to make significant contributions to great challenges. And those are not just scientific challenges. Those may be challenges of access, challenges of equity, challenges of how power is distributed. So we think a lot about open source and the way that goes. We want to build our grantees' discoveries into research platforms, into concrete data sets, into ways of evaluating that can impact the whole field. And we also want to, we know that the best ideas come from interactions and people. And so we want to sponsor conferences, create convenings, create opportunities for people to come together and work together. We specifically fund those. So right now, this is maybe, these are 3, 4 major projects that we have in AI and advanced computing in my group, 4 major grant-making projects, and 1 at the end, which I will discuss. So I'll start with AI 2050. This is, I think, one of the more prestigious fellowships in artificial intelligence today. It's about 75 faculty members. Maybe 3/4 of them are early career, so that's within 5 years of their PhD. Some are more senior, and it is a fantastic fellowship. It involves an amount of money where you can pursue a research project strongly, but not have a lot of annoying oversight from people like me telling you what to do. This is a really often hands-off, because AI is changing so fast and moving so quickly, and new things, reasoning models, and fine-tuning, and guardrails. All these things are changing so fast that we believe that programs, research programs in AI, have to change that fast too, just to keep up. And so it would be a speed bump, and actually, frankly, intellectually pretentious of me to tell researchers who are the best in the world what to do. What I want them to do is pursue it themselves. And that is what the AI 2050 program is about. We have a brand new program in safety science, and I will mention Nicolas Flammarion from EPFL, who is a recent grantee. We just started that program, and it's all about trying to build the science of safety, not to build I don't know, specific evaluations of toxins, but more in LLMs or something like that, but more to develop methods that are firmly grounded in metrology, in understanding the way that these systems work, so that the measures we have are in a scientific way related to the phenomena we want to measure. Another exciting thing we're doing, and this is, we call it Schmidt Sciences, but this is an example of our breadth, is to use AI to advance scholarship in the humanities. And one of the things we announced in Paris is a project with Sorbonne and the Louvre around the French painter Delacroix, who painted these enormous murals. Except he didn't paint the murals. He had a studio. There were students who also were up there getting paint on themselves and painting the murals. So there's always been this question in art history: what part did Delacroix paint? So we have a project to try and assist art historians here, but there is an AI connection to this. And that connection is this. If you think about the way we evaluate AI models now, we tend to do it on things that are easy to check, objective. Tests of biology knowledge, coding, mathematical theorem proving, engineering problem solving. Maybe hard to set up, but easy to check. With the Delacroix, there is no ground truth. Nobody was around to say, what portion of the mural was painted by Delacroix himself and what portion was painted by his students. There is no ground truth. The standard of scholarship is what arguments can you create to convince the connoisseurs of Delacroix. And that's interesting. That's not something we see in AI. But I contend this area where you don't have ground truth is actually characteristic of most human knowledge. You think, where are some of the greatest intellectual achievements of humanity? They're in places like religion, history, literatures, languages, philosophy. All of these areas which don't lend themselves to checking via multiple choice. And so we hope in the Delacroix project to really start shedding light on how we would evaluate LLMs in all of these other areas. Finally, we have a project on AI at work. That's an easy one to describe. Everyone says AI is going to take your job, but nobody knows what to do after that because we don't actually have any data about this, about how companies are actually pulling AI in, changing worker productivity, changing the structure of employment. We don't have very much data on this at all. It's just floating in the air. And so that program is about getting that kind of data. And finally, there's a big question mark here around AI for science. We are Schmidt Sciences. You'll notice that we have basically no AI programs in science. That's kind of embarrassing. And so we're going to change that. And I will, in the next slide, talk a little bit about this. And this is my last slide. So the title of the talk was AI, Science, and Philanthropy. And so to address this topic, I figured, well, the way to do that is those are three things, and they fall into three, by combinatorics, fall into three two-element sets. And so this is how I'm doing it. Science and philanthropy, right? How do we think about those two things together? Well, I've already mentioned the public good aspect. We're always trying to increase the public good. And there's a huge history of this, of course, in philanthropic support for diseases, for general biomedicine. And I believe the speaker who comes after me will talk in much more detail about this. But our job at Schmidt Sciences is to sort of fill in the gaps underneath that, take that early risk, and complement public sector support. Let's think about the AI and science interaction. Well, AI is the best, large language models, or basically deep neural networks, are the best systems we have produced to find complex patterns and their entailments in large data sets. And so we have a thesis that AI, this set of algorithms and techniques and hardware support, will be as impactful in science as the telescope, the microscope, the particle accelerator, the computer. There is a saying that a really powerful tool changes its user, and we think that that may happen here in AI. And so there's two buckets, what we call discovery science, so that's AI for materials discovery or chemistry or some field, geology. And then there's also AI for the science of discovery. What can we do to help AI come up with interesting hypotheses? How can we make AI work in open-ended reasoning? How can we think about AI and conceptual structures which are not purely embedded in language? And so the balance between these is, I think, fairly delicate. But that's our job as we come up with the AI for Science program, is how to balance these two things. Maybe you can guess, I like the science of discovery a little more than discovery science, but we shall see how that turns out. And finally, to close, I'm going to talk about AI and philanthropy. Remember, and this is why I get up out of bed every morning and why I'm so privileged to be at the philanthropy that I am, working with significant sums to try and support this. Philanthropy has always been about social missions. It's been about civil society. It's been about the public purpose. It's been about building the public good. And that's incredibly, incredibly rewarding. And so if you think about where in AI is the public good going to be, it's in places where there's often market failure, right? Places where the companies are not going. So that's things like safety. How do we think about safety and assurance? How do we think about risk? There's been this huge debate about existential risk versus near-term harms. How do we think about that? And how do we think about access to artificial intelligence for all the people in the world who are not part of the wealthy Europeans or 5 or 6 companies on the United States West Coast? How do we think about AI access for those people? And how do we think about the kind of assurance that would allow us to make AI a truly beneficial force worldwide? So this is what we think about in AI and philanthropy. And with that, I will thank you for your attention. And I think Marcel and I will be taking some questions.
Thank you, Mark. If you can maybe take this chair, and I'll take this one. So as always, there's going to, there it is, the QR code for you to post questions, but I'll already get started. So first of all, thank you very much. This was super interesting. I want to double click a little bit on that issue about safety and the complement, as you mentioned it, to public sector investment. So how do you think about this, especially now that we live in a time where some of that support from the public sector, whatever remains of it to be seen, is falling apart? Does that mean, how do you think about this? is that a way for you to say, well, if we cannot work with the public sector, it probably means we cannot work in this area at all? Does it mean you're actually going to invest even more? Well, what's your thinking in that area?
Yeah, that's I do not have to reiterate the challenges we have recently had in the public sector in the United States. I wish I had a crystal ball to figure out where those are going to go. But we think about it in a couple of ways. Number one, we try and set up for the public sector, but we think about the public sector globally. We don't think about it just as Schmidt Sciences is a United States foundation, but we don't think about it just as the United States. We think about Canada, we think about UK, we think about the European Union, we think about Switzerland, we think about all of these different areas where if the United States decides to not play the game for a while, then we can find others whom we are de-risking. And these problems are universal, right? AI safety is not going to go away. And for many applications of AI, we need to have some assurance beyond just, well, it did it fine the last 100 times, that we can deploy AI in these contexts. And so, so there is turmoil in the United States. The amounts of money which the public sector provides in the United States are 2 orders of magnitude larger than the amounts that philanthropy provides. We cannot fill that hole. We cannot turn up the heat. But we can continue to march forward. We can continue to go and try and solve those fundamental science problems. We continue to work globally, and we continue to hope.
So when you look at the safety issue, so one could argue, I think a lot of people, when they think about, okay, who's going to be responsible for AI safety, right, to make sure that this plays out in a safe way, they're probably immediately thinking of regulation. And that certainly has to play an important role. But your approach is different in the sense that you're saying, well, that probably is important, but there's also a more engineering and technical aspect to this. How do you see those two interact?
Yeah. I think so. Thank you. So I think that I have a I don't know, benefit, but I have a scope at Schmidt Sciences. Schmidt Sciences does not do policy. We do not support policy analysis. We do not support the lobbying of governments. We do not support legal analysis. That's not our role. There are other philanthropies that support that. That is not our role. Our role is to create the fundamental science that would inform any good policy. Because underneath policy disagreements, well, let me back up. I think that it is not possible to resolve policy disagreements until there is basic agreement about the scientific phenomena about which that policy is being made. And so we go forward thinking of that. Now you ask about how we think about regulation. We certainly try and track the AI Act. The regulatory environment in the United States is changing very rapidly. We watch the regulatory environment in China and Southeast Asia and India. We still think that those are policy decisions that are made by people who are not us, people who are not scientists, but who hopefully will be informed by the science. We also think that, for instance, in safety, we may not be able to prevent people using custom-trained models to do bad things. The model, those technologies are there now. But what we can do is, through our support and research, help people or help researchers build, have a good pathway to build safe models. For some definition of safety, for some set of safety properties, people dispute what safety is, but for some set of safety properties, we want to create that capability so that if somebody wants a safe model, there will be a scientific foundation for how to build it.
Mm-hmm. Okay. So let's take a couple of questions. So one is, the choice of the projects. Obviously, I think it's great. You have a foundation that says we want to help with with, for example, the safety issue. Now, how do you? Of course, there's a foundation, right? There's a board makes decision. Is there a process by which you also try to understand what a more broader public wants in terms of safety, or is that an independent decision making?
So we have 1 minute and 40 seconds left, and so it would be difficult for me to go through the processes. But I can say, yes, we do try and understand the views of the affected populace. In fact, we do funding in areas of like democratic assembly and AI work, and so we not only try and understand that in selection, but we also try and create more of that kind of foundational knowledge in this area. And when we actually do make the choices, we have input from, actually in the AI 2050 case, well over 300 people worldwide who help us make those decisions. You could say they're a selected few. In fact, maybe that's a valid criticism, but at least it's not, 8 people in a room.
Yeah. So let's merge 2 questions here. So one is about geographic spread. The other is about the role of Europe in the AI game. So what's your thinking there in the foundation about this?
We have a explicit goal of funding in places other than the United States, Canada, and the United Kingdom. As I say, we have one of our first safety grants here at EPFL. We have some other work in other countries in the EU. We have some work in Southeast Asia. We have 2 or 3 grantees in India. We have 1 in South Africa. So we have different geographic spread, and it's one that I am quite proud of. It turns out it is sourcing projects in those areas is difficult. It's work, and we have advisors who help us, and I think we're getting better every day. But our ambition certainly is that AI is a global technology, and the research work that we support should be equivalently global.
Okay. Excellent. Good. So let's close. I want to thank you for the support that you give. I mean, not only to EPFL, but I think it's worthwhile iterating that, we sometimes take these things for granted. There's government funding. That's, of course, great. And that's also societal needs. But I think philanthropic foundation doesn't need to exist, right? Somebody could just also retire on an island and keep the money in a bank account, yet they decide we're going to actually fund research. And I think that's sometimes a bit underappreciated. So we certainly appreciate it a lot. Thank you very much for all you do.
It's a privilege. Thank you so much.
Thank you.